Hi everyone, this is group 13 and I'm Baratu Thuleya. I'm going to present number one. Number one, we were given the probability of having a disease and testing positive, which is 0.9, the probability of not having a disease, 0.9, and the percentage of the population with a disease, 1%. We were asked to find the conditional probability that a person has a disease. To get this, you get the product of the probability of having a disease and testing positive times the percentage of population with a disease divided by the total probability of testing positive. To get you first get the percentage of the population without the disease. You get 100% minus 1% and get 99%. And also get the probability of not having a disease but testing positive, which is 1 minus 0.9 and get 0.09. So to get the total probability, you get the probability of having a disease and testing positive times the percentage population with a disease plus the probability of not having a disease but testing positive times the percentage of population without the disease, which is 0.01 times 0.9 plus 0.99 times 0.1 and get 0.189. So to get this, to find the probability that a person has a disease, you get 0.01 times 0.9 divided by the total probability, and the answer is 0.0833. Thank you.
Hi everyone, my name is Gift Mercy Namaganda. I'm going to present question 2, question 3, and question 4. So we'll start with question 2. It's saying they've given us a small grocery store has 10 cartons of milk. So they've told us 2 of them are sour. That means 8 of them are good. So they tell us if you're going to buy the 6th carton of milk sold at random, find the probability of selecting a carton that is sour. So basically the concept behind this question is it's about discrete random variables, right? So our selection is going to be random, and the probability of selecting a sour carton of milk is 2 out of 10. So our answer would be 2 out of 10. And when we go to question 3, we have 2 events, Q and S. They have told us they are independent. And they have told us the probability of at least one of them occurring, which is probability of Q union S, it is 1/3. And the probability that Q occurs, but then S does not occur, it is 1 out of 9. So they want us to find the probability of S. So to better interpret this question, we use the Venn diagram, and we interpreted it in our layman's language. And when you draw the Venn diagram, you will find out that the probability of S is going to be 2 out of 9. So when we go to question 4 is talking about a family that has 5 children, and they tell us the probability of having a girl on each birth is 0.5. That means also the probability of having a boy on each birth is 0.5. So they tell us all the 5 births are independent. So they want us to find the probability that this family has at least one girl, given that they have at least one boy. So when you read through this question, the concept behind is about conditional probabilities. So that is how we answered the question, and we found out the number of combinations in this sample space is 2 power 5, which is 32. And next, when you continue and break down the question, you find out and you calculate, you find out the probability of at least a girl, given that at least a boy, it's going to be 15 out of 16. Thank you.
Hey everyone, my name is Nabanjo Rebecca, and I'm going to be taking you through number 5, number 6, and number 7. And number 5, we are given a shipment of 240 television sets, whereby you had 15 which were defective. They told us to find the probability that they were both defective. So, now if I'm speaking, I'll be having 15 out of 240, and on my second picking, I'll be having 14 out of 339. So to get the probability that they were both defective, I'll be multiplying those probabilities. To go number 6, we are given 500 people, and we were told that 382 like ice cream 362 like cake. So we are told to find the probability that at least one of the two, that at least we are trying to find how many people like both if each of them likes at least one of the two. So we are told to use the formula of probability of A union B, which is equals to probability of A plus probability of B minus probability of A intersection B. So, and we well know that probability of A union B is always a 1. So I had to use that formula to find the probability. After finding the probability, we have to use that probability, then multiply it by 500 to get the number of people. Going on number 7, we are given a box with 5 green balls, 3 black balls, and 7 red balls. And they told us 2 balls were selected at random without replacement. And they told us to find the probability that both the balls are of the same color. Meaning on my first picking, when I have a green ball, also on my second picking, I have a green ball, same as for the black balls and the red balls. So we had to find those probabilities, and it's better to use a tree diagram, which helps us to find a final answer. Thank you.
My name is Kizito Rodney, and I'm going to be presenting number 8. Number 8 was requiring us to find the sample space of the random experiment, which consists of tossing a coin until the first head is obtained. Then the question is this sample space discrete? So the solution for this, it's like in this experiment, we toss a coin repeatedly until the first head appears. We stop immediately once a head is obtained. So the possible outcomes here are H, meaning the first toss is a head. Then TH, meaning we get a tail followed by a head. Then TTH, meaning 2 tails followed by a head. So therefore, the sample space is S equals to H, TH, TTH, and so on. This sample space is discrete because the outcomes are distinct and countable. Even though there are infinitely many outcomes, we can list them one after another. Therefore, the sample space is countably infinity and discrete. Now, going on number 9, the question is, find the sample space of the random experiment, which consists of tossing a coin infinitely many times. Then, is this sample space discrete? Now, the solution to this, it's like in this experiment, a coin is tossed infinitely many times, meaning the process never stops. Each outcome is an infinity sequence of heads and tails. Now, one example of this is you can have two heads, 2 tails, then 1 head, 1 tail, like it continues forever. Then you can have all tails forever. You can have alternating forever. That is head, tail, and so on. So each outcome is an infinity string of H and T. Now, unlike question 8, this sample space is discrete. It's not discrete. This is because the set of all infinity sequences is uncountably infinite, meaning the outcomes cannot be listed one by one. Therefore, the sample space is not discrete. This marks the end of our presentation for group 13. Thank you.